Hi, I'm Burkhard Maaß. I'm a material scientist, one of the founders and CEO of Ingpuls, and also the CEO of Ingpuls Smart Shadings.
Hello, I am Miguel Callejas. I am a Spanish architect and I am the creative director of Ingpuls Smart Shadings.
Ingpuls Smart Shadings is a spin-off or subsidiary of Ingpuls GmbH, where at Ingpuls we produce and develop shape memory alloys and actuators. In the Smart Shadings spin-off we develop and later produce shading solutions based on shape memory alloy actuators.
Basically, we can use these shading applications anywhere you need a shadow for thermal comfort. That can be outdoors or indoors. For example, outdoors, it can be used in streets, in public space, streets, squares, parks. And inside the building, indoors, it can be also used in patios, empty spaces inside the buildings, attached to the facades of the buildings. And another example of application outdoor could be in the south of Spain, in many shopping streets. They use these shading devices so that people can get rid of the hot weather and enjoy shopping. So it's demonstrated that it increases the sales of these shops. Well, it all started one hot summer day in Sevilla, in the south of Spain. I was walking in the city, and there they used these shading devices on top of the streets to provide shade for these commercial shopping streets. And I was walking there and I thought, okay, this is a really good idea. But the same day at night I came back through the same street, and then I saw these, we call them toldos, shading devices, and they were still on at night when they are not needed anymore. And then I started thinking about the idea of moving architecture, something that, because architecture is so static, and then at that time I was also looking for new materials, researching new other things, and then I found shape memory alloys, and then I thought, okay, this is the perfect material for this. And then I started reading articles, watching videos, getting material, and then to get some samples of material I sent an email to a nice company in Germany, and this is when I wrote an email to Burkhard, and then something happened really funny. What happened, Burkhard?
So the story on our side, I'm sitting in my office in Bochum, and I get an email from a Spanish architect from Sevilla, but he writes me in English, and I thought, hey, this guy, he surely speaks Spanish, and I answered him in Spanish because my part of the story starts a little bit earlier when in 2005 I went to live in Sevilla and to study there for a year. And so when I got his mail, I immediately knew what he was talking about because I knew the toldos, I knew Sevilla, I knew the weather, and I knew shape memory alloys, and it clicked, and I knew what he wanted to do.
He replied in Spanish, and I was like, wow, that cannot be, this is incredible.
And I told him, I know where you live, I know your street and everything, and so this was really cool. And then
happy coincidence.
We started, since I didn't know what he wanted to do, then we wanted to make this system work, and he was looking for spring actuators. But so far he had just bought them from online stores where you always just get short springs, but he wanted to make more displacement. So I just started to make this piece by piece, an actuator here, an actuator there, to see that he could make his prototypes. And we didn't have any funding or anything, and at first we didn't know that he was not from a company. And said, okay, if you want to make this an R&D project, it costs like this. But then he said, yeah, well, I'm just a PhD architect and I don't have any funding. And then, he made his prototype and his thesis in 2016.
At that time I was working in my thesis, and then Actually, I asked Burkhard if he could come to be part of the members of the thesis jury.
Yeah, and then I went over, we met there for the first time, and up to then we just had made video calls, and that was 8 years ago, and it was not that common. We still had to use Skype and this old software, but it worked, and so we got to know each other.
Burkhard told me, hey, we need to continue this, maybe we can ask for money to the German government, and that's what we did.
We wrote a proposal for a TIM project together with the university, with the chair of material science, and after some time it finally got approved, and this was in 2018 when the project started, and Miguel just packed his stuff in Sevilla, loaded it into his old Renault Megane,
and I got the car and I came to Germany, 2,500 kilometers.
Yeah, and this was really amazing. This was for us really impressive, because who would do that? Who would make such an thing just to pack your stuff and go to live in another country where you have never been before in a new city?
If you really believe in something, you go for it, no? You go for it. So. Yeah. And I was so lucky to find them here. They are such nice guys. They know the material, they have the technology, and I am in the best place possible to be.
And this is where we are. This is where we are today.
This was the story.
Every day, new challenges arise. So, in the early stages, it was just a little bit. Naive understanding of an architect and not a material scientist. He sees this material and thinks, okay, I can just do this. But the real world always brings up some little details of the actuators. If you activate them once and again and again and again, then they will have some sort of functional fatigue, which is known, but brings some issues on how to install this. For example, the system between two walls. And the effect is, it's not small, it's not big. If you think of the additional length on a spring actuator, but if this actuator is several meters long, it is a significant length. So these were obstacles, technical things, design things. Then Miguel's idea was to have a system that automatically opens in the morning and closes at night. So the way that shape memory alloys work is you have one transformation from martensite to austenite when you heat up, and you have another one from austenite to martensite when you cool down. For that you have a hysteresis. Both transformations do not happen at the same temperature range. And what we learned when we looked at weather data was that the actual difference in the streets is not big enough even for our small hysteresis alloys, so that this works without a little bit of help. And then we started to look into other solutions. What do we have to do? We found out that heating up is something that we can help artificially by additional elements, but cooling down is something that is really hard. So we decided to develop an alloy that would cool down at the right temperature in the evening, and then having the heating up part at elevated temperatures with an additional element. These were some of the obstacles.
Exactly. At this point, I would like to highlight that for me it's really interesting the mix of Spanish architects and German engineers. Burkhard knows this material very well. He knows all the technical aspects. So he puts me in the right way, let's say. He puts a bit of limits in these things that I am always thinking about, and it's a really good team, I would say.
And of course, these were the alloy challenges. Then you have system challenges. You see that always there's some part where there's friction and it breaks. So not breaking apart, but breaking, like in taking away speed. You always have some little mechanical things that should move, that don't move, and all these things you have to solve step by step. Yeah, these are the technical challenges. Of course, you also have organizational challenges is first, do we get the grant or not? Can we write the proposal and will it be granted or not? So all these things have been solved step by step. Then are other things like, now we want to make a system. This is 3 by 3 meters. Where do we put it? We don't have enough space, because that was in the days where we just had like our garage office. So Miguel invented a little thing where he could lift the whole system below the wall after working. And these are things that you have to work on. Of course, we have to say also the impact of the development from Ingpuls itself was sometimes a challenge, because when we started out, it was 2014. We were just a few persons in the company, and while we were writing the grant proposal for the CIM project, we got at Ingpuls side our first automotive contract, and we had to set up our production line, which really took most of my time, and I could not always have the time and energy just focusing on the smart shadings. But these are things that we have learned to cope with.
We had a lot of problems and difficulties in the past, but we still have them. The way is not finished, but we have learned a lot, and this knowledge is something that we have, that we take with us, and that will surely be useful for the future in every. So we are happy in the point that we are now. We learned a lot, and we continue learning, and hopefully we will get to a nice result.
An important thing, just talking about challenges in the past and challenges that we have overcome. We have now a validated prototype who has already demonstrated more than 10 years of service life, so we know that the system really works. And this is something that all of the team can be proud of. I think it might be the longest SMA actuator ever made. I'm not sure, I will not take it to Guinness Book, but I'm pretty sure that this is a really long actuator working for meters and meters. And we have calculated then that one single point of this actuator has already run a marathon.
Yeah,
and this
couple
is really cool.
Couple of them, 2 marathons, yeah. So it's really exciting, yes.
Yes.
Well, the benefits of smart shading solutions, we are noiseless, we don't produce any sound, we are faster than conventional systems, we have a system which is lightweight, and we don't need extra space. Like in a normal system, you need maybe a motor, bigger or smaller, but you need this space, you don't want to see this. So that means that we can integrate our system, because we are smaller, in the building, and that means you see nothing. You can see maybe a big textile moving, but you don't really see how it's moving. You don't understand what is happening. It has a bit of magic component, and we love that. I think this is really cool.
And of course, it's not magic, it's material science. And the good thing is that, as Miguel says, it's lightweight and smaller, and that brings another important thing is that we don't have such an impact on the building structure. So we don't need a lot of supporting structure on the building. If we, for example, make drills in the wall, drill holes in the wall, it's much lighter and much more elegantly designed. Mm-hmm. Another thing which we have not talked about before is that we produce 2 kinds of system. One is an active system, which is activated by electricity, and you can just control it with an app, open it, close it whenever you want. For that, you need a source of energy. The other system is the passive system, where we just use the heat of the sun. And there you don't need cables, you don't need anything to control it. It will just open and close when there's sun and when there's no sun anymore. So these are perfect for huge spaces, for public spaces where you don't want a maintenance or something, where you just install the system and it works all by itself.
Exactly. I would add that the passive system is a really smart system, in the sense that it really feels the sun, the material itself. We don't have sensors or any other motors in separated parts. The shape memory alloy itself has all these functions together. So it's a really smart system, I would say. And the active system, it's a system that the user can control. It's perfect for private space, like in your garden, in your building. And the passive system is perfect for the public space, to be used in streets and squares, so that they don't need to be activated and deactivated every day. They don't need maintenance, and I think this is good for public space.
Sustainability, the word is all around us and you hear it everywhere. And we think, what is our impact on sustainability, on using less energy? If you have a building or a space and it's standing there in the sun, it will heat up. If you want comfort, you will take your air conditioning and to cool it down. And this takes a lot of energy. We think it's smarter to prevent the building from heating up in the first place, by closing the windows, by creating shade. And then if you don't have the heating up of the building so much, then you need less energy to cool it down again. This is one aspect. The second aspect is that if we take our passive systems, we don't need additional energy to create the shade, so the system will close by itself. And you have to think not only about the system itself, but also of the infrastructure. If I don't need meters or kilometers of cables running to my shading systems, this is again less impact, less products that I need for creating the shade. And we are working in accordance with the guidelines of the EU, which want to have shading for buildings more and more. Miguel can talk a little
Exactly.
bit about
The European Union is planning by 2050 to save around 60% of the energy used in buildings. That means around 100 million tons of CO2 emissions, which is great, and we would like to be a part of that. But also I would highlight that these systems provide also thermal comfort, which is good. We don't want to feel hot, we want to feel a good temperature when we are in the street, when we are in our building. And if we get this thermal comfort and we also save energy, even better.
I like to add another point, which is, not just looking at the application of our systems, but also of the life cycle. So our systems have a very low complexity. So they just are built of a few simple parts, and that also means that they can be dismantled very easily. And we can put these things to recycling. We can even recycle our shared memory alloy actuators. And this is a very big point. Today you cannot just think about the application of a product. You always have to think of what happens after the product is disposed. And the less complex a product is, the easier it is to recycle.
Also, I would add that Burkhard knows this better than me as an engineer. The more simple a system is, the longer the lifetime of this system, and we are also happy with that.
So right now, we are a company. We have founded Ingpuls Smart Shadings last year. We have worked on the prototype. We would say that now we are at TRL 6, maybe. We have a proven prototype. It's not just a lab thing. And now we want to make the next step, which is going from a prototype to a serious production and actually going to market. And for that, we are now preparing everything to start talk to investors.
Exactly. We are a young company. We are almost 1 year old only, but we already have these prototypes working. We have 2 patents pending also.
In addition to our smart shading systems, we are really happy, and we will soon announce that we are part of the CERAF consortium. And this is a project from the European Union, a Pathfinder grant, which has only a 5% chance of approval, and we got it together with colleagues from Italy, from Holland and from Spain. And there we will develop a system which is familiar to our systems, but which is not a shading system, but an opaque facade. And Miguel can talk a little bit about that.
This is a system that we will develop a facade module, something that you can repeat many times to build a whole facade of a building. And we will do the outer layer of this system. The outer layer will consist on several elements, shading elements that can open and close, so that when you want shading, you have shading. So when you want sunlight, you have sunlight. And we are really excited about this. This means that we will be able to reduce the energy consumption in buildings almost completely. Energy consumption in heating and cooling, which is really interesting.
And again, this will be driven by shape memory alloy actuators.
Exactly, yes. We would like to start first with our shading devices in the private sector, so that you can get it and use it in your garden, in your building. But also in the public sector, in Spain, these shading devices, we call them toldos, they are really well known there. They have been in use for many years, and we think it could be a really fast application. And then finally,
the question of when will we be ready? Well, we want to have the first systems installed in the market next year. So in 2023, I would say by the end of summer, that would be nice. We're looking at our future customers. We want to get their feedback, what they really think about the product. And how we want to do this is to install pilot systems in public spaces, so that people can really play with the technology and see how it works. And then to see what they really think about it, because we think it's really cool, and everybody we talk about it, and everybody who we show the prototype thinks it's really cool, but we have to get out to the field and see what other people think about it. As we explained, we are a small company. We came from just a bootstrap, doing a part by ourselves thing, to a TIM project, which helped us through some years. And then we got some seed capital from Knellman Ventures, which was a really nice story, which is a really good contact. And now we are preparing a Series A financing round. And we are preparing the business plan for that. And this will be open. And with that, we are going to approach investors, and investors who might be interested in investing in us, in our team, in our technology, can just approach us, and we will be happy to open the communication with them.